Okay, so now we just solved this problem and we found out that the period of rotation for the moon is around 28 days. We know that a month is actually 30, 31 days, something like that. So now, moon and month being similar, how is it that we say a month is a moon or a month is a period of rotation? All right, this is where things get a little fun. All right, so now, if we are talking about the orbit of the moon around the Earth while the Earth is orbiting the sun, that's where things get a little freaky. All right, this is the sun. You can tell because it's round. All right, so now here is Earth, and as Earth travels in this direction, the moon rotates in this direction. Notice, and the sun orbits in this direction, or rotates, revolves in this direction. And so all the planets go this way, all the moons go the same way. This is the idea, except for some things that have retrograde motion because of astronomical collisions with comets or whatever. Like some Uranus is like tipped way sideways, and there's some moons that spin backwards.
You avoided saying it.
Yes, I did. All right, so the idea is this. Now let's go back to here, and I'll erase some of this stuff. As Earth goes around or the sun and the moon goes around Earth, I want you to think about something. I'm going to draw them the same size, and I'm going to put a dot on the moon. Okay? So as the moon goes around, Earth comes around this far. It comes a 1/12 of the way, about 30 degrees in a month. Does that make sense? Roughly. Now, the moon, as it orbits Earth, goes all the way around. So for Earth and the moon to be lined up sidereally, all right, sidereal means with respect to the stars. So if we're actually, you know what? Let me make it a new moon. Makes it a little easier to see. If we have a new moon and we're looking at the moon, right? We don't see the moon, right? Because it's all dark. So the moon lines up down here with this field of stars down here, which are so far away that there's, in essence, they come to us as parallel lines of light. That's the way that we accept that. So now, for the moon to go all the way around Earth, the moon is going to be, for it to be exactly one orbit around Earth, is going to be pointed this way so that it is one orbit with respect to the stars. You see what I'm saying? But in that amount of time, Earth has moved over here. So for it to be another new moon, the moon actually still has to move a couple more days until it's a new moon again. Right? So in other words, relative to the stars, it only takes this 27.3 days to come around relative to the stars, so that the line from Earth to the moon points to the same star all the way down here. Okay? But for it to line back up with our local star, which we call the sun, it has to come a couple extra degrees, right? An extra 30 degrees, which takes another 3 days, approximately 10% longer, right? To come back around. So a new moon takes several days longer between new moons than it does for the moon to actually orbit one time in terms of the specific definition of the orbit. Make sense? So that's why it's so much shorter. Okay, counterclockwise depends if you look at it. All right, answering Ryan's question really quickly. It isn't always counterclockwise. It just depends on if you're looking at it from the top, quote top, or the quote bottom. But what we really see is that there's a consistency. Everything orbits the same direction, right? And things orbit this way, and things orbit around these things in the same. So basically what we're doing is we're conserving this orbital energy, right? So what it really is angular momentum. Because the model that we use to describe how a solar system would form would be what we call the protoplanet model, okay? What happens is just large swirls of gas and dust, okay, are brought in by the gravity, some place where there's an extra concentration of matter. So it just starts to bring matter in and starts to increase its not its angular velocity, its rotational velocity, because its angular momentum is conserved as it goes around. So as parts of it break off or end up having their own little orbits or their own rotational dynamics, those are all going to be consistent with a rotation that is around an axis this way. By the right-hand rule, that would be pointing out of the board. if you're used to that notation right there. Okay? Because it all starts from an initial gigantic rotation of a large mass of gas and dust. And then so anything that breaks off from within that will retain that angular momentum.